Hello, today we solve this question and it says that if epsilon equals the set A, B, C, D, and E, the set P equals A, B, C, and the set Q equals A, B. Which of the following statements is or are true? So we have I, Q is a subset of P. P complement is a subset of Q complement. P complement union Q complement equals the universal set, that is epsilon. When we write the sign, that is epsilon, and that is the universal set. So we've been asked which of these is true. So let us look at it very well. First, we have the sets A, B, C, D, E. So that is the universal sets, and we have the set P to be equal to A, B, C, and the set Q is also equal to A, B. So the first statement that we have, that is the I, says that Q, that is the set Q, is a subset of set P. Now, if we say the set Q is a subset of set P, then that means that all the elements in set Q can be found in set P. So what are the elements in set Q? These are the elements in set Q. We have A and we have B. So if we go into set P, we also have A, B, C. So it is very clear that we can find all the elements in set Q in the set P. So this is true. Indeed, set Q is a subset of set P. So that means that where we have I should be the correct answer. And if you look at what we have here, we have I here, that is the option A. The option C2, we have I and II. The option D, we still have I here. It is only the option B we don't have I. So this means that the B cannot be an answer. So let us go on and check the II2. Now II, it also says that P complement is a subset of Q complement. Now there are two ways to do this. Now one way is to find P complement and also to find Q complement. Then you try to find out whether the elements in P complement are subsets or can be found in the set Q complement. Let us try that one and see. Now first, let us try to understand what we mean by this. Now if we write this P and we have the sign over there, we call it P complement. Now when we say P complement, it means the set of elements in the universal set that are not in the set P. Yeah, so P complement means not P. That is the elements that are not in P. So we have the set P, of course, that is the set P. So the set P is, within the set P, we have A, B, C. So if I write P complement, then it means I am talking about the set of elements that are not in the set P. So P complement is like not P. So, from the universal set here, that is the universal set. Universal sets, yeah. So we have A, B, C, D, E. So that is the set of elements in P. If that is P, P is A, B, C. So if I want P complement, then I am talking about the set of elements that are not in P. So P complement means not P. So I have A, B, C in P. So here I have A, B, C, which are the set of elements in P. So those not in P are there D and E. So P complements, I will have D and E. Now in the same vein, if I talk about Q complement here, Q complement is also the set of elements in the universal set but not in the given set Q. Of course, there is the set Q. The set Q, I have A, B. So if I'm talking about Q complement, then I'm talking about not Q. Not Q. So in Q, I have A, B. So those not in Q, those elements or members not in Q, of course, they are going to be C, D, and E, because in Q we have A and B there. So the set of elements that are not in Q are going to be C, D, and E. Now the second thing that I have to do, I'm done with this, so I just have to come to the II and check and see. Now there is P complement, and I have P complement here, and there's Q complement, and I have Q complement here. Now this symbol that you see here is called a subset. Subset. So you see that it is a C, is like a C, and where it faces, that is how it is read. If I write something like this, A, and I do this, that is read as A is a subset of B. Now if I still write A and B here, but I change the sign to face backward like this, because it is facing A, I now read it as B is a subset. So where the sign faces becomes the superset, and where it doesn't face is the subset. So in this case, because the sign is facing B, B is the bigger set, that is the superset, and A is the subset, that is the small set. Now in this instance, because the sign is facing A becomes the bigger set, that is the superset, and B is the subset. So with this one, we read it as B is a subset of A. So if you look at what we have here, what we are saying is that P complement is a subset of Q complement. Is it true? That is a question that we're asking here. So let us look at P complement. P complement, we have two elements that are D and E, and Q complement we have C, D, and E. So do we find D and E in Q complement here? Do we find a set of elements in P complement in the Q complement? Of course, we see D here, and we also see E here. So this means that the II is also true. So if I come and check it over here, because II is also true, then that makes the option A to not correct, because in the option A there is no II. So I'm left with only two options, that is the option C and the option D. So I is correct, II is correct. I have it in option C, and option D too, I have I and II. So I am left with the option D. I have to check and see whether III is also true. So we have III here. All right, III also says, so let me write it here, III. It also says P complement union Q complement is equal to epsilon, that is the universal set. Is this also true? All right, I know P complement. So where is P complement? I have it here. There is P complement, that is DE, and I have Q complement also here. Now the sign that you see here is called the union, and of course I think that you understand the meaning of the word union, to unite, to bring something together. So if we have P complement union Q complement, then what we are trying to say here is that if we put the elements in P complement with that of the elements in Q complement, do we get a universal set? That is the question that we're asking here. So let us try to find the set P complement union Q complement. Now when I put these two sets together, I have D and E here, so I'm going to do it alphabetical order. So I'll start from C. So so this will be C, and of course I have C here because I am putting these two together. So C here, and have D here and D here, but I'll write it D once, and I have E here and E there, and I write the E also once. So the sets P complement union Q complement gives me CDE. So is this CDE equal to the set epsilon, that is the universal set? Let me go back and check here. Now according to the question, epsilon equals A, B, C, D, and E. So if I check this P complement union Q complement, I see only C, D, and E. There is no A, there is no B. So that means the III is not also correct. It's not true. So that means D is not also true. So the only correct option that I have here is the C. All right, let me show you another way that you can do this, a very quicker way that you can do this. And I'm going to do it over here. So I'm going to start with the first one, I. The first one is pretty easy to, see. The first one says that Q is a subset of P. Is that true? I'm going to look at the Q. Where is the Q? That is Q. So of course, Q, I have AB, the sets AB, and then P2, I have ABC. So I can find A in A and B in B. So of course, I is true. Now let me check the second one here. The I have P complement is a subset of Q complement. I do not want to find a complement. I've been given the sets P and Q. So why should I have to find the sets P complement and Q complement before I can verify the authenticity of this expression? I can change it. There is something that we call De Morgan's law. Let me write it here. De Morgan's law. And De Morgan's law says that the union of two sets is equal to the intersection of their complements, or the intersection of two sets is also equal to the union of their complement. Let me try to write it down for you to see. That's what I'm trying to say. For example, if you have something like P union Q, that is the same as if you take the complement of the entire set here, you have is something like this. You take the complement of this entire set, you have P complement, and if you take the complement of the union, you have intersection, and you have Q complement. But unfortunately, we are not dealing with intersection and unions here. So how do we apply this even to the subset? It works in the same way, or let me say in a similar way. So with this one, I have P complement is a subset of Q complement. So all that I have to do is to take complement again. It's something like if you have, say, -4 and you don't want the negative, you have to negate it again so that you get +4. So I don't want a complement, so I'm going to take the complement of the whole of this, and this will be true. So if I take the complement of P complement, that will change to P. And if I take the complement of this subset sign, the sign will change direction. And if I take the complement of Q complement, the complement will go away. So that I do not have to find anything like Q complement or P complement, because I already know my P and Q. So I will now come and check. Look at where the sign is facing now. The sign is now facing the P. It means P is now the superset and Q is now the smaller set. So I have to read this as Q is a subset of P. But the question is Q a subset of P? I have to go and check that. Where is Q? Now the set Q has A, B. And where is P? The set P has A, B, C. So is Q a subset of P? Can I find the elements of Q in P? Of course I can, because there is A here, there is A there, there is B here, there is B there. So that makes the II true without even finding P complement. I have applied De Morgan's law. Now the same thing can be applied to the III. Sorry, the III. Sorry, that is the third one. Okay. So the III also says that P complement union Q complement is equal to the universal set. I don't want to find this complement because I wasn't given any set called complement. I was given the set P and the set Q. So how do I do that? By applying De Morgan's law. And that is what I'm going to do. I will just have to take the complement of the side, because what I'm trying to say is that P complement union Q complement, if you take the complement of everything, what you get, the two must be the same. So the complement of P complement is P, and the complement of the union, this will change to intersection, and the complement of Q complement will be Q. So the new question is that is P intersection Q equal to the universal set? That is the question. So I'm not dealing with complement again. So I'm going to check P intersection Q. So where is my P? My P is ABC, And where is my Q? My Q is AB. So what is P intersection Q? Okay, I have ABC, then I have AB. Intersection simply means that find the set of elements that can be found in both sets. So let me write the intersection word, something like that. So I can find A in Q, A in P, so A is part of it. I can find B in Q, B in P, so B is also an element. So this is P intersection Q. So instead of finding P complement union Q complement, I found P intersection Q and I had AB. But the question is this equal to the universal set? Of course not. That is not equal to that, because the universal set is A, B, C, D, E. But here I have just A, B. So that means the statement I is not also true. That reaffirms the fact that the only true option here is the option C, that is I and II. Thank you.